Hey, welcome back. I'm here again with my Voron V0 printer. We've got the mini stealth burner print head that came with it now replaced with this dragon burner. And so now that the physical printer is basically in the state that I want it to be, we're going to get down to doing some more fine tuning with the physical aspects of the printer, and then we're going to do some fine tuning in our slicer to try to get this thing printing at the level of quality that I'm after. And so the first thing I want to try to take care of today is the subject of belt tensioning. And I don't know about you, but for me, when I built my bigger Voron printer that's back there, and then also again with this one, a big sort of question that I always have is, did I get the belt tension right? You know, because the instructions have you like pluck the belt and try to use maybe an app on your phone or something that listens for pitch and frequencies to try to figure out visually by looking at the app what the frequency is that the belt is vibrating at, and you're going for a certain frequency, and I think you can get kind of close that way. But I've always wanted to see if there was a way that you could be more precise than that. It's always just kind of bugged me with both of my Voron printers now that I don't feel like I've got that belt tension just right. And so recently I stumbled across this project here. It's this little device which you can print the parts for this and build, and we'll do that in this episode. I'll go back in time to past Mark and I'll show you how this was built and calibrated as well. But what this thing is, it's a little spring-loaded tensioning device where you can push this in, fit it between the belts, and measure a more precise value as far as what the belt tension is. So let's throw this back to my past self, and I'll show you how to put this together and calibrate it, and then we'll come back to this printer and we'll use this thing and see if we can get the belt tension dialed in more precisely than what we did with just the trick of plucking the belt and listening for a frequency. So yeah, let's build this thing first, then we'll try it out, and we'll get my kind of final impressions at the end as to whether I think this is worth doing. I think it probably is, but we'll play with it a bit first and then decide for sure. So let's get going. All right, so let's build this belt tensioning meter. This was designed by DIY Shift, and I will link to their GitHub page that has all of the parts and instructions that you can print and the instructions to look at to build this thing. I'll put that down in the description of this video, as I always do with resources that we use. And yeah, printing this was fairly simple. They do request or suggest that you print it not on a textured surface, and so I have a mostly smooth PEI bed that I like a lot on my big Voron printer, so that's what I used for this. It came out nice and smooth because these parts are going to have to slide on one another, so you don't want to have too much of that textured surface. I did print it in the same white ABS filament that I used for many of the white accent parts on the V0 printer that we're going to use this to test. And so everything came out good. I took a black marker and just kind of went quickly through these tick marks on the little meter here, just so that they'll be easier to read. So I just fine tip black marker to color those in. All right, so let's get this thing put together. The only hardware that we need is what's here on the desk, a couple of screws. Again, it's listed in the bill of materials on the GitHub page. And for me, all of these things were extras that I had from my LDO V0 kit. So I didn't have to buy any new hardware, with the exception of this spring, which actually came in a small bag. So I've got some extras now of these springs. And then also the piano wire that we're going to use with this tool here for calibrating the thing. So this package of piano music wire, and you want to make sure that it's the right size because the thickness of it matters for calibrating the tension on our spring. So both of these things, this and the springs, there were Amazon links in the bill of materials on the GitHub page for this project, and I just used those links to download exactly the same products to make sure that I have everything exactly the way that it should be as far as the tension on the wires and the springs and such. So yeah, this should be everything that we need, and then also a little bit of lubrication of some kind to lubricate the sliding parts. And what I'm going to use there is just the same Mobilux grease that I used to grease my bearings on my printer. And so yeah, I've got that in this little tube here, and we'll dispense this onto either toothpicks or Q-tips as needed to spread it around in all of the places that we need. They ask you to make sure to kind of inspect your prints and make sure that like the teeth here and also on all of these little needles are good and clean, and that when you printed them, you didn't have like seams lined up with those. So I made sure in my slicer when I printed this that there weren't any seams on any of these gear parts, because the precision of these teeth is important, right? So we start out with this little arm piece, and we need to grease up this little channel here where the spring is going to slide inside of it. So I'm just going to grab a little bit of grease here on the end of my Q-tip and just use that to spread down in here. Just in that part. Nice. All right, and now we can assemble our little spring assembly. So we've got this piece here, and they've got these little nubs on them that should fit into the spring. This little piece tried to escape, but we've got it. So it goes like this, and then we can just push them in to this channel right here. Maybe easier said than done. There we go. And the tension of the spring holds them in place. You want the side with the holes here for the screw heads to be facing upwards towards where this bump is what it looks like on the instructions. So yeah, we've got that all assembled and ready to go. And now we can just slide this part into here. And they note that it should slide, really easily, right? If you've got too much thickness, or maybe you've over printed something here, you might get some binding on that slide motion, but we're good. And so these two holes that are right here where my thumb is are going to be where we screw this piece down into, I believe. And that is what they want us to do next. So with these two M2x10 self-tapping screws, we're just going to try to find those two holes down there. That was easy. And I'm not sure if we're supposed to tighten these down all the way yet. I think we can tighten them fairly snug, and then we may have to loosen them for an adjustment later on to get everything lined up just right. But for the moment, we'll do that. So now we should have this sliding motion. And actually, that does seem very smooth. Nice, so I'm happy with that. And then they talk to us about these needles. Now, they give you, I guess, 6 different ones, and they suggest that they have a little tick marks on the back side. Let's see if I can show the camera so you can see if it'll focus. Yeah, so this one is the 4. It's got 4 little tick marks right there. And the only difference, I believe, between all of these things is the size and spacing of the teeth for the gear part at the top. So they suggest that we start with the number 2. And what we want to do is we want to lay this down here with the Roman numeral or the tick mark side down, and this side with the circle in it facing upward toward us. And we're going to line that up right there. But what it's going to need is it's going to need the washer below it. So we're going to put the washer right there. Then we're going to put this, and then we're going to use this M3x6 to just screw it down into place. So it's a bit tricky to get everything lined up here. And we want to line the teeth up so that the arrow, the pointer, is pointing all the way up at the 0 as we tighten this down. And we tighten it all the way down to snug, which should make it so that it doesn't move very easily at all. And then we back it off just a touch so that now it can move. So now when we push our plunger, this is moving down, right? Now the thing that they want us to check is how much backlash we have in the gear meshing right here, right? So if I don't let this thing move, if I hold this really solidly so that it's not going to shift up and down, how much play do I have at the end of the arrow up here? And the answer is actually quite a bit, like almost a tick mark and a half in my case here. And so the number 2 arrow is too small for what I need. And so what I've got to do is take this one off, and then they want you to trial and error this with all of the different numbered arrows here until you find the one that still moves nicely when you move the plunger up and down, but that is not loose enough that it slides around. And so I've actually already done that off camera before we started, and what I discovered, at least for me, is that the number 5, the biggest number, is the one that actually fits the best here. And so I'm going to go ahead and we'll give that a try just to be sure that that is true. but my testing indicated that it should be. So again, making sure that this is pointing up at the 0 so that the teeth mesh correctly over here. We'll tighten this down. And it can't move, and so we back it off just a little until it can. Maybe it needs to back off a little more, but we'll adjust the looseness of that later on. So now again, I'm gonna put my finger here so that this thing can't move at all, and then I can see that this is really solid now. Like I can't really shift it at all, but it does move nicely back and forth with this. So for me, this number 5 needle is the one that is the best choice. Now, once you figured that out, then they want you to reassemble this thing and lubricate it, right? And so what we need to do is take this screw out one more time, and be careful all the times that you're doing this in and out with this screw, because it is threading just into plastic, right? So you don't want to over tighten and strip that plastic. And again, we're going to take some of our lubrication here. I'm going to use a toothpick this time because it's just a little bit finer of a device for applying. I'm going to put some of it on the top of this little washer here, and then I'm going to put some of it on the underside of our gear here, and then I'm going to get a little bit more, and I'm going to put it in the teeth of the gear. So just making sure I get a little bit smeared in to all of these teeth. And again, this is why I think the toothpick is a good choice here, because it's a very small little gap that you want to try to press this lubrication into. All right, and so that's what the instructions want us to do, and then at this point we can line this thing up one more time and hopefully screw it down into here for the last time. Again, tightening it all the way till it, it just barely moves, and then backing it off enough that we get a nice, more fluid movement. Then I'm gonna actuate this thing a bunch of times just to kind of spread that grease around and make sure that I'm happy with the movement, that it's nice and fluid. All right, now we have one more problem, it looks like, which is that when this is all the way back, the needle isn't quite pointing at the 0, it's actually at like 0.1. And so I think we can adjust that by loosening these two little screws here and allowing this little block here to shift back just enough, yeah, so that that's right on the 0, and then with that right on the 0, we'll tighten this back down. All right, so that's looking good. That lands on 0, I can press it, it goes way down here, and when I let it go, it lands on 0 again. Yeah. All right, that seems good. Now, the only thing left to do is to calibrate our tool here. And so there's two parts to that. The first is, and I've already done this, and I couldn't really undo it to show you again on camera. They want you to take a piece of that music wire that is 100 centimeters long, or 100 millimeters, sorry, long, so 10 centimeters, and cut that. And so I did that. And then this printed part here has a very tiny hole in either side, and they want you to feed that in so that the end of it comes all the way down to here. And that hole was so small that once I did that, it was going to be really hard to pull this wire back out because it was a very tight fit. And so, yeah, I just left the wire in there. And they asked you to put a drop of super glue on either side just to hold it in place. So all this is a 100 millimeter long piece of this wire. Sanded a little on the end just to get the burrs off after I cut it so that I don't accidentally cut myself with that thing, and then just placed into this printed part. So we're going to need that, and then we're going to need this last M3 screw, and it goes down here into the hole in the bottom of the handle. It's going to press up against that tensioner piece that we put at the bottom of the spring right at the beginning of the assembly here, and allow us to tension that spring. So if I can get this to line up with the hole so that it will go in there. There we go. Okay, so that is fed in and started, but what we need to do is take this and place this over this round peg there, and then push our handle in and feed this, above and below. those two things, and then we let go, right? And so what we're looking for is, they remind us here 1.9 is what we're looking for. So we want to adjust the tension on our screw here until we get that reading right at 1.9. So as I'm tightening this down, that's moving down. Now, one thing you probably want to do is just kind of tap the device a bit to let the needle settle into place whenever you make a change. So for me, now it's maybe a little bit too tight. I'm going to just loosen it ever so slightly. Pump this a few times to make sure that I have exactly the tension that I want. Maybe a little bit less. That was too much. It is, you know, actually quite sensitive. Like a very small amount of turn on that screw will produce a fairly large result here on the meter. So there, now we've got this right at 1.9. We can, you know, remove this, make sure it goes back down to 0. I'm going to put it back in and test it one more time just to be sure. Yeah, that's looking pretty good. It's actually maybe a little bit too tight, so I might want to loosen it just a touch more. I think it's worth taking your time to make sure that you're happy with the calibration, because if you're going to use this tool, you know, to adjust the belt tensioning on your printer, you want to be fairly confident that it's where you want it to be. So yeah, that's looking really good. I'm going to give it just the tiniest turn to tighten it up just a bit more. And now it's landing right on the 1.9. So that is excellent. All right, and so there's our tool. They give you this little slot right here, so you can actually store this tensioning piece like that when you're not using it, which is, I think, a pretty smart idea and very helpful, so you don't lose your calibration piece. But then again, of course, you're going to take that off when you go to measure the tension on the belts. So this thing's ready to go. All right, so we're back here with the tensioning tool and the printer, I think, ready to be calibrated here. So it has been a couple of days since I built this thing, since the video or the segment that you just watched. And so I'm going to go ahead and take the little tensioning helper here, the calibration tool, and go ahead and feed it back in here one time just to try to see if we can be sure that this looks right. So kind of tap this thing and let it settle out, and it does still point at the 1.9. So that's looking good. All right, so we can set this off to the side, and now we should be able to just fit this over the belts and see how this works. Now, because this V0 has a very short belt path, I think probably the best thing to do is just to move the print head all the way to the back. We again want to make sure that it's centered left to right as well, so that our lengths of belts are as close to equal as possible. I know this one's in the middle because it was parked up here in the front middle for unloading filament most recently, so if I push it straight back, we should be good to go. I have the printer powered off, by the way, right now, so that moving this thing around manually isn't going to cause any issues. So I've gone ahead and loosened both of these belt tensioners, these little knobs, completely as loose as possible. And just to see kind of where we were starting with. And I expect this to be super loose. Yeah, it's like so loose that it's reading at 0. Should be the same on the other side as well, right? Because we counted the same number of teeth when we built the printer. So what I'm going to try to do is tension these equally. So that was very not scientific, but I tried to turn them both about the same amount. This one's actually easier to get to because the belt's a little bit higher. So we'll start with this one. We'll see where we ended up. So hopefully you can see that. I tried to color these little tick marks in with a black marker so that we could see them better here for the video. So I'm at about 1.6 right now on this side. Let's switch around over to here. See what we get over here. Oh, make sure that is on there. Good. Yeah, so I'm at about 1.5 over here. So I'm going to just continue to tension them so that they're equal with one another. So I'm going to bring that one up to 1.6. So they're both 1.6 now. Hey there, it's Editing Mark from the future. I wanted to break in real quick and answer one question that I think you might be having, and that is, how do we know what level to tension these belts to? So if we look at the GitHub page for this belt tension meter, and you scroll all the way down past the assembly instructions and the calibration instructions, you'll get to this little table here that is the tension guidelines for different printer models. So if you're using a standard Voron configuration, we can look here and you can see what tension reading you're after. So our meter reading we're after here for A and B belts is 1.9, and so that's what I'm going to be targeting here in this video. And then if you, for my Voron 2.4, I also used this thing to tension those belts. So again, 1.9 was what I was after on the A and B belts, and then for the Z belts, they want you to target 2.6. So just because I don't think I said it anywhere else in the video, I wanted to make sure that you knew that this table exists over on the GitHub page, and you can use that as a reference to figure out which level you're looking for on your tension meter. All right, back to work. I'm going to take this one, and I'm going to turn it like 1, 2 small turns like that, which took it about to 1.8. This side, one, so this one's a little bit trickier, I'm finding, because the print head kind of interferes with the handle here. Also, the camera's not wanting to stay focused. But this one I've got right at about 1.9 now. So that's looking good. And again, you want to tension these, as far as I understand, pretty equally, on both sides. Like, you don't want to tension one all the way to the level that you think it should be, and then switch to the other belt, because that, will possibly introduce skew. Our X and Y axes are so short on this printer, we're probably not going to get too much skew from unevenly tightened belts like we would on a larger printer, but this is good. All right, so now both of these are at 1.9, or at least that one is, and this one was close, so I bet that it is now. Let's see. Yeah, so they're both sitting right at 1.9. So whether or not this thing is perfectly accurate, is maybe up to interpretation. Assuming that this calibration with this little wire here is accurate, we should be really close. But even if it's not perfectly accurate, at least we know the belts are equally tensioned with each other, because we used the tool to tension them that way. I'm just going to pluck this and hear what the sound sounds like. Yeah, so they're making about the same tone, and I don't remember. I should have probably plucked them before I made this adjustment, just to hear what it was previously. But that, to me, sounds a little bit higher pitched than what I had calibrated them to before. So I'm pretty sure that I had them, when I had used the app to do this, that I had them a little bit too loose. And just for your information, I did this same procedure with this tool on my big Voron 2.4 as well, and what I discovered there is that my X and Y belts were a little bit loose, a little bit too much slack. I think they read at about 1.7 on here, and so I tightened them up to the 1.8, 1.9 range. And then I also found you can use this on the Z belts for the bigger Voron 2.4s as well. My Z belts were all slightly too tight, so I've loosened those up. And one thing that I definitely found with the Z belts on the 2.4 is that equalizing them out using this tool, and this is just anecdotal, right? I have no scientific measurements to prove whether this is true or not, but it seems like to me that equalizing those Z belts has helped the quad gantry level to not have to run quite so many passes around the machine each time. As long as the machine doesn't lose power, it seems like the gantry's staying more level between prints than it was before. So, again, anecdotal evidence. I didn't, take any official measurements before and after or anything like that, but I do believe that this on my 2.4 has helped to keep things more evenly balanced for sure on the z-axis. So that's been interesting. All right, so now this printer I think is now physically ready to print. In the next episode, we're going to do a little bit more calibrating with specifically I think with the extruder. We're going to tune pressure advance on here. We'll probably do some other stuff as well related to just kind of global settings within the printer config to make sure that we're printing in a consistent way. And then we'll probably also do a test print to check skew here as well, because I mentioned earlier, we want to make sure that we don't have any XY skew on our printer, and with a small print area like this, we probably don't have any noticeable skew, and hopefully I squared everything up really nicely when we built it anyway, so we don't have that problem, but it's worth checking. So we'll do those things next time, and then we'll, in the episode after that, probably tune up some new filament that I've just gotten in that we're going to use for a bunch of our test prints, and then we'll get to doing some of our initial test prints on this printer. So that is the plan going forward. Get subscribed and follow along on the playlist if you're interested in all of those things, and I will see you next time. Hope you have a good day.